James Dean, a specialist in creating three-dimensional schematics, is using technology specifically designed for ancient discoveries to investigate.
When a superconductor is cooled below its critical point, the way in which electricity flows within it changes. If we take this superconductor and we place it in the presence of a magnetic field, you can see that the field lines of the magnet are inducing a flow of electric charge within the superconductor.
These currents form tornadoes of charge called vortices, with the magnetic field passing through their core.
If we zoom in and take a closer look, you can see that the vortices of current that the magnetic field has induced are passing through any little tiny defects they can find in the superconductor.
These defects pin the vortices, and therefore the magnetic field, in place.
If we move the magnet, we're moving the magnetic field with it, which means that the vortices are being dragged away from their pinned locations. So they're resisting this movement, and if we push it and pull it, we can see that it's trying to pop back into place. In fact, we'll find that any force which tries to move the magnet, and thus the magnetic field, will be met by an opposing force, which tries to return it to the same location.
And this is the key to stable levitation. The pinning of the magnetic field opposes the very force of gravity itself.
So the magnet is locked in place because its magnetic field is locked in place, and it levitates above the superconductor.
If the superconductor is moved, the levitating magnet will follow it, flying at the same height along a plane. So the magnet not only levitates, it can also be moved stably through the air.